Let's talk about significant figures. Significant figures are needed in science because when we write down a number, the number shows not only the value itself, but how well that number is known. In other words, how many digits we show tell us something about the accuracy of the measurement. In the lecture part of the class, a lot of times you're just dealing with how many places do I use, or how many digits do I round to when I do a calculation. But in lab, you also have to consider how do you write down a measurement. When you take a measurement in lab, how many digits do you record? So let's just take a couple of measurements and see how this works. First of all, this curved line is called a meniscus. And so if I'm measuring how much liquid is in this graduated cylinder or whatever, most of you have probably heard that you want to measure from the bottom of the meniscus. But what does that really mean? Some people think that means that you're going to measure at the bottom of the U shape, so right in here, and they would measure from the kind of the middle of that black line. And that's not quite right. You really want to measure from the middle part, but you want to measure from that bottom edge of the black line. And so I'm just going to draw a line kind of straight over so I can see where it comes up. And I'm going to take a measurement from the bottom edge of that red line. Okay, so when I go to take my measurement, the bottom edge of the red line is definitely between 3 and 4. There's a line for 3 and there's a line for 4, so I can write that digit with certainty. The next digit, though, there's no line for every 0.1. So I'm going to have to estimate between the 3 line and the 4 line, and I would estimate that that is about 3.3. So that is my estimated digit. You always estimate one digit between lines, only one digit. Better put some units on there. So that takes us back to the definition. Significant figures are all digits known with certainty. There is a line for those, and one that is estimated between lines. Let's try this other one. And let's just say that on this one, let's just say the meniscus looks like the bottom edge is right on that little line there. So when we go to write down the measurement, it's definitely between 1 and 2. There's a line for that digit. And then the next digit, there's a little line for that. I believe it's 0.6. So there's a line for that. And then we need to estimate one in between. We always estimate one digit. Since that appears to fall right on that little line, I'm going to estimate a 0 here. And that completes my measurement. So always look at what your smallest line represents, and then you'll go one place beyond that. When you do calculations, you'll need to be able to count sig figs in given numbers. So this is just like a little game. It's how I tell people to approach it. Learn little rules, and then you'll be able to count sig figs. And after a while, you won't have to think about the rules. So you'll just do it, and the longer you do this, the more sense it kind of tends to make. So at the beginning, I think it's best just to kind of treat it like a little game. The digits that are non-zero always count, and I put lines over my sig figs to show that they're significant figures. So all of those count as significant figures. Zeros that are sandwiched count, so all of these count as significant figures. All of these count as significant figures. It doesn't matter here that there's more than one that's sandwiched. However many are sandwiched in there, they count. Leading zeros never count. So on this number, only these two are significant. It doesn't matter where the decimal place is. All of these are leading zeros and they don't count. On this one, the sandwich one counts, so I have 3 that are significant there. Okay, ending zeros count if the number shows a decimal point. If you see the dot, you have to actually see the dot, there it is, then ending zeros count. So these 3 count. Leading zeros never count. This ending zero counts. this looks kind of funny, 100 dot. Well, that dot makes these digits significant, so it's important. And then, of course, all of these are significant. If there is an ending 0 or ending zeros and there's no decimal point shown, technically that's ambiguous, but what we assume is that they don't count. So on each of these I would have just one significant figure, and that's very different than if there were a dot shown. Now they are all significant. It's better to use scientific notation if you have ending zeros where there's no decimal point shown. This comes up when you have larger numbers and you need to cut them off, round them off up in this area up here. So for example, for this number, to write it with one significant figure, I would write 2 times 10 to the third. For 2 sig figs, I would say 2.0 times 10 to the third. For 3, 2.01 times 10 to the third. 0.0. Very good. So I've put it in scientific notation. Notice that there are some other options. For 4 sig figs, I could do this. And for 1 sig fig, I guess I would understand it if we wrote this. That would have 1 sig fig. The problem with writing it this way is that it looks like it's an exact number, and exact numbers don't have sig figs. They're perfect numbers, or you could maybe say they have infinite sig figs. So it's very important that we recognize when a number is exact, because that won't affect the sig figs in your answers when you go to round. We'll talk more about exact numbers here in a little bit. But anyway, so this is how you count sig figs. Let's look at our rules for multiplication and addition and subtraction. When you multiply and divide, there's one rule. The rule is you look at the numbers that go into the calculation. This one has 4 sig figs, this one has 3 sig figs, and the one with the least sig figs will limit how many you can have in your answer. So this is what my calculator says. I'm going to round that to 3 sig figs. So like this. Notice that I rounded up because I look one digit to the right. If that is 5 or greater, I'm going to round up. So 179. And then we need to think about the units a little bit here. This is centimeters times centimeters. So that's centimeters squared. That's area. Let's look at addition and subtraction. When you add and subtract, I recommend that you write down the numbers lining them up, because you're not interested in how many significant figures they have. You're interested in how far they extend to the right. Okay, so when I line them up, I look at how far they extend to the right of the decimal. Both of these numbers go to the 100ths place, so I'm going to line them up like this and then use how far they extend to the right to decide where to cut them off. So in this case, I'm going to keep all of those digits. I'm adding grams, so this answer is in grams. Notice that I went from 3 sig figs, 3 sig figs, and here I have 4 sig figs. That's fine. When you add and subtract, sometimes you gain sig figs and sometimes you really lose a lot of sig figs.